Hello, and welcome to Fernando's Corner. The topic for today is broadband multi-wavelength systems. It has been one of the holy grails, and certainly a hot topic this last year, the ability to segment HFC nodes optically and in a broadband manner. To help illuminate us in this topic, our guest for today is Kuang-yi Wu, one of the optical masters here at Cisco. Kuang-yi, welcome. Thank you for being with us. Kuang-yi, it took many years for the industry to tackle this problem, and certainly the solution was not easy to get to. What are some of the fundamental issues that made this problem so challenging?
Several constraints on both fiber and optical component. First, on the fiber nonlinearity. Take a stimulated Raman scalarity, which create energy transfer between wavelengths, and you leave the crosstalk. It sets a limit of how wide the range of the wavelength can be. Then there's the fiber four-way mixing effect, which is the third-order fiber nonlinearity. Okay. Actually, it depends. The strength of this four-way mixing depends on how close those wavelengths are to each other and how close they are to the zero dispersion point. But as you move away from the zero dispersion point, you have to deal with the laser, the chirp, and the dispersion distortion. So you cannot go just too far away from the ZDP. In addition, there's the optical mux and demux also may introduce the phase to amplitude distortion. So it is a hot problem.
So there are various parameters we generally track for quality of service in HFC. Which of these parameters ended up being the most sensitive in these multi-wavelength systems?
Yeah, there are three actually, and also actually in addition there will be four actually very important performance parameters for the analog transmission system. First is the signal to noise ratio, we call it CNR, and the second will be the second order distortion, composite distortion, we call it CSO, and the third order actually is the composite third order bit, we call it CDB. For the Kuang actually signals, we also need to consider the bit error rate, BER. Because of the crosstalk, the multi-way system, the CNR and CSO are the most sensitive. We also need to pay attention to the crosstalk in the narrowcast Kuang channels.
So Kuang-yi, is there a limit to the number of wavelengths we can put down a fiber, and why?
Yes, because of launch power, there's a trade-off between how far the fiber link can be and how many wavelengths you can put into a single fiber. Most likely, a wavelength will be a limit for very short fiber lengths. For practicality, we have released 6 wavelengths only for up to 20 kilometers, and 4 wavelengths can go up to 25 kilometers. The maximum number of wavelengths is dominated by the fiber nonlinearity, both Raman and the four-way mixing.
So the optical band, Kuang-yi, is huge, right? Why do we choose the O band for this exercise?
Yeah, it is a very good question. The optical band is huge. Theoretically, the communication window for the single mode fiber is about 50 terahertz, very wide. The key reason to use O band is to use the intrinsic low fiber dispersion property, which allow us to use the very cost-effective directly modulated laser. The range has been most deployed in the field of the FFC network for the very same reason, so no need for change.
So Kuang-yi, going forward, looking at the future, what could be some of the next hurdles that a technology like this would have to tackle or would like to tackle to keep going forward?
I would say polarization. All fiber nonlinearity are polarization sensitive, but until now we design our system, multi-way system, by taking any kind of random polarization state into account. Going forward, we would like to either control or arrange the polarization, which enable us to put down more color, more wavelength, and go farther fiber lengths.
Friends, this is an extremely exciting and interesting and very deep topic that Kuang-yi has just presented a tiny introduction to. If you have any questions, feel free to contact Kuang-yi here at the Naperville facility, or myself, Fernando. Certainly leave your comments on the blog. And until next time, thank you for coming to Fernando's Corner.